So I want you to go ahead and this one, yeah, you probably already have the answer. But oh, it changed one. Probably because that was a very large number. So we just, you know what? I'll just scribble over the top of it when we get there, and hope that's the only one that we changed. Alrighty, try number 1. What is it? 3. And if you have trouble, remember what we did was we said we don't know what it is. Let's snail shell it, and that'll be a 3. But my hope is there won't be any work there or anything. I'm sorry. No, if you look at that and you say that's 3, bam, that's what I hope. I'm showing work. Well, that's work. All right. Now, as we get to the fractions, that's usually where people stutter step a little bit, and that generally is where it really does help with the snail shell thing, so you can see what's going on. But give number 2 a try. What is this one, everybody? In case you didn't hear Joe before. It is 4. So, how do you know there's no negatives, there's no fractions, or anything like that? Because it started as a fraction and it finished up as a fraction. There was no flipping involved. So, we don't have a negative power involved because it's still a fraction. If one is an integer and the other one's a fraction, that means you need a negative. You had to flip it. But this doesn't need flipping. And then you realize, well, 1 to any power is 1, so I don't care about that one, but I need to figure out 3 to the something is 81, and that something is 4. Now, we're going to change this number. You had 256 on yours, right? Good. So give this one a try. Might have to do a little multiplication after the side.
Oh, got it. Don't say anything. Salt. I got it.
Yeah.
4.
So, did you do the actual multiplication?
I did.
Yeah, and that's kind of what I see. Generally, when these numbers get bigger, I'll actually see people writing this down, and that's what you have to do if you can't use the calculators. Just go through. Okay, how many times did I do this? Now the problem is keep track of what power it is, because I do see people take this test, write all this stuff down, but they didn't put these powers on here as they were going through, and then they write like 3 down, which makes no sense, you know. So keep track of things, keep organized. All right, try number 4.
What is Alabama? I think I got it. I hope I got it. Those idiots.
Let's give some other people a try.
I'm not totally sure though, that's the thing. Oh, actually,
Okay.
I don't know.
This half of the room, what's the answer?
Alabama.
It is not Alabama. Joe was trying to draw you off. -1/2. That's what it is. So we look at this and say, not a fraction, fraction. Here's the whole problem. What do you do to 64 to get it to be 8 as a power?
Negative 1/2.
It has to be a root. It's smaller. So you think, okay, which root? Oh, square root. I have to write it as a power. Square root's 1/2 power. Exactly. And you got it. All right, give 5 a try, please. Who's out of the room?
-5.
Okay, you're just joking.
-5.
-5. It was a fraction. Now it's not, so that's a negative. And we need 2 to the 5th to get 32. All right, try number 6.
You look in the middle too. I'm on this half of the room. It's easy. Oh.
Got it right away?
Yeah.
They're inverses.
Oh my goodness. That's... Wait, what?
The 2 bases are x.
So when you do x to the something equals x to the 7.
So, just me talking, but if I'm taking this test on Friday, I'm going to go through those 6 immediately and look for one of those first. I'm going to find, is there an inverse situation here? Put that one down right away. Then go back and do the other ones that are thinking problems. This is not supposed to be a thinking problem. It's supposed to be these 2 bases match. Those are inverses. They're out of here.
That's a knowledge problem.
Power. It is. It's a power. Knowledge of logarithms and powers and how they work together.
You gotta know your stuff. You gotta be thinking up here.
Go ahead and grab your calculators.
Oh.
Now we'll go on to the portion that you're allowed to use calculators for.
Oh, backs.
Try number 7.
Already got it.
Oh, shh.
Hold it. First subtract.
This is why we want to do the second.
Got it. So what does it still go?
Okay, I'm not going to ask what the answer is. I want to know steps. What'd you do first?
Subtract 12.
We should. Remember, the base has to be exposed.
I just realized that.
I know. This is one you can do by the bases being the same. Now, if you're going to use logarithms, yes, you absolutely need to divide by that -1. But if you just say, I know what 4 to the something is, 64, we just did that, which is, yeah. But you definitely could, I mean, this is fair game at this point, because we did the whole chapter now. So you could say, those are inverses. X is going to equal the log of 64 divided by the log of 4. And you can grab your calculator and just change the base formula. You get 3. All right. Go after 8.
You have to solve. You have to solve. You got to solve. I know, Eli.
It's another C word, Eli. It's not pesto. Nets.
Isn't that? Oh, that's what I. Wait, we should get nets. What's the difference between that and compress?
Compressions are for our graphs.
I just think of. Hang on, I haven't.
You're right. I mean, it basically means fancy words. Looks like a few people need a little help on this one.
Yes.
Okay, so if we have logarithms and we need to solve, we have to snail shell. But you can't snail shell until you have one logarithm statement. So for one logarithm statement, you're going to have to condense, which means you need to know what subtraction means in logarithm language. Division.
Was that you too, Eli? Yeah, I got there, but then I was like, what do you do?
You snail shell. If you don't want logarithms and you want numbers, you snail shell.
So
Remember,
it's just log.
called exponentiating
Oh,
in the book.
it's like there. I could have got that. Really, 10.
At 1,000. Oh, base of 10.
Yeah.
LOG. And I would probably slap a 1 over and just cross multiply.
I was like,
Logarithms, we need that language gone so we can find the number answer. To get rid of it, you snail shell. But to snail shell, you have to have one logarithm, and it has to be logarithm, one thing equals one thing. Yeah, your book used base 10 a lot when we were solving a lot. Alrighty, give number 9 a try.
That's what I got. I think it's like, I'm pretty sure.
So the question you need answered is, can we snail shell that one anyway?
Absolutely.
But there's an x minus 7 there. Shouldn't we add the 7? No, we can't. They have to stay grouped together. That's what parentheses mean. This part right here is grouped together. Now, if the parentheses weren't there, absolutely we have to add 7 to both sides, but they are there. 3 to the 4th? Did you know 3 to the 4th right away? Couldn't help it, right? Our book used that so. Did you?
Yeah. Calculator.
We use that a lot in chapter 6. That 3 to the 4th seems to pop up all the time. So x equals 88. Hey, is that checkable? Sure it is. You put your 88 up here and you say 88 minus 7 is 81. You can even use change base formula in the calculator to get that for if you want it. There it is. All right, go after 10.
Oh.
That drastic.
Oh, yeah. You have to divide by 3. I don't know. I just feel like start something the wrong way and then I just need some refreshers. After I get refreshers, then I hopefully I'll just forget. It's 8 hotel at a 8.
So everybody, did you divide by 3 first?
Yeah.
Have to expose the base. How do you get rid of that base of e?
Ellen.
Natural. And then it's calculator time and reminder. When we are putting logarithms in the calculator, 4 decimal places. Always go 4 decimal places for logarithms. So you might need to punch that in quick again so you can write down your rounded answer there.
1.097.
That it is.
Good job, Eli.
So the base has to be exposed, or the logarithm has to be exposed. You know, those are the 2 ways that we go with these, either the base or the logarithm. So now, use that knowledge. Remember 7.
Good job, Eli.
Are 6 minus 3 natural logarithm of x.
This is a cool. No. Never mind. It's not cool. Because what I did was I subtracted the 9. I got to M. Is it x equals negative 1? Ooh. Is it 1 over e equals x? Oh my gosh, how do you do that? This is right. Oh, I got it right.
All right, everybody, what's step 1? Subtract 6. Then what? Divide by negative 3.
I got it right.
And then lots of people got stuck. Is that a logarithm or isn't it? You need to snail shell. But you need a base. What's your base? Yes. Natural logarithm is base e. So logarithm base e of x equals negative 1. Snail shell it. E to the negative 1 equals x. It's on your calculator. Push those buttons.
Oh, we actually have it's 7.
What?
E to the negative 1.
What's that? 6 on the 5.
Yeah, don't use the ln anymore. E to the negative 1. Well, that's a pretty good stopping place for today. That'll leave us 12 through, what is it, 22, I believe is the last topic.
What are we going to do for the rest of the day?
And I did notice, of course, that some of you are already doing problems, which is okay if you feel you know exactly what you're doing. But if you're looking at it and you're saying, I think we did this, then don't do it. Because we need to go through it so that you remember it correctly when you go through it. So you got the little slip of paper yesterday that has the review on there. That's what you need to be working on. Get at least partway through that. Some of you probably need that little slip of paper.
I'll take